Hey guys, no joke to start this time. Unfortunately for you guys, I want to talk about roses today, and roses are going to be functions of the form you see on your sheet there, either r equals a sine b theta or r equals a cosine b theta. With sort of no restrictions on a and b, right? They could be, they're think all was integers. Let's just say they're always going to be integers, but they could be, a could be negative or positive. Yeah, so let's dive into it. Let's say that we wanted to graph r equals 3 sine 2 theta. 3 sine 2 theta. And again, I always like thinking about the graph y equals 3 sine 2x. It turns out that there are going to be a lot of parallels there, and we can really label a lot of things. We're going to go kind of slow for this one, but I want to sort of label some peaks and valleys of this guy right away. So I'm going to label each of these green points my peaks, each of these red points my valleys. And I'm going to be concerned about these blue points too, my zeros of my function. All right, let's think about all those guys. And let's just go ahead and plot them, right? We can plot those right away. Again, I sort of have a rough sketch of some of a t-chart over here, with some values that you guys could find. But, it turns out I don't necessarily think that we need them as much. So all of my blue points are obviously going to be at the origin, right? Because r is 0 there. All right. And then where are my green points? My green points are at pi over 4 comma 3. Pi over 4 and 3, 3 comma pi over 4, I guess. Where is that? That's 1, 2, 3, let's say. I keep on talking about these guys. Is theta comma r, right? They are r comma theta, right? That's really 3 comma pi over 4. It's just, when we have the t-charts here, it just feels like, the theta should be x and the r should be y, right? But that's really 3 comma pi over 4. And the other guy would be 3 comma 5 pi over 4. So that's maybe way out here. Similarly, my red guys, those are negative. So at 3 pi over 4, instead of being out this way, we're going to be at negative 3. So that's all the way out here. But similarly, when instead of being out here at 7 pi over 4, we're at negative 3. So that's going to be out here. So we actually hit both points. We just hit them sort of in an opposite way. Okay. And then the other thing that I'm going to do that is a little bit different than how we graphed our limacons, I'm going to just put in some dotted lines here along all of my zeros. It's sort of asymptotes. They're sort of guidelines. Okay, so I'm going to put one at theta equals 0, right? This straight line. And I'm going to put one at theta equals pi over 2, because that's another 0 of my function. No idea why that line is so much thinner than the other one, but who cares? And then my other ones are actually already drawn, right? Because we drew one at pi. We just happened to draw it at 0, and 3 pi over 2, and at 2 pi. Well, we don't really care about 2 pi because we care about 0. But here are some lines that are going to guide us. Now let's turn our attention to this first t-chart here. And I'll use, purple's obviously the best, so we'll use purple for the first guy. Okay, and let's think about what's happening here, right? We're going from, theta's going from 0 up to pi over 4, and it's getting big pretty fast. And if we look at the xy graph, it's getting big fastest close to the origin. And that sort of gets smaller or increases at a slower rate, right? So what that is going to look like, right, if we sort of pencil in these guys, pi over 12 and 1.5, that'll be like out here. Pi over 6, 2.6, that's all the way out here already. right? And so on. And what this is actually going to look like is actually going to look like this. It's going to increase very fast at the beginning, and sort of level off. And here's its peak, right? This is the farthest R can get is up here. Oops, should still be green. Still be green. The farthest R can get away over there is all the way up here. And then what's going to happen here? R is going to come back down, and we're going to run back into the origin, sort of along this pi over 2 line, right? Not really an asymptote, but sort of a guideline that we don't want to cross it, right? We don't want to cross pi over 2, and it's going to sort of come back in like this, right? And we see that actually made a little petal of a rose. And if you think about the graph of y equals 3 sine 2x, that should make a lot of sense to you, right? That we, as we sort of moved around in this direction for theta, right, r got farther away, and then it got closer, and everything was always positive. Everything was always positive, right? Let's think about sort of our next little valley here, right, between pi over 2 and pi. So ordinarily, we'd be thinking about these angles up here between pi over 2 and pi, right, in the second quadrant, right, the top left. But everything's negative in that world. Everything's negative in here, so we're actually going to think about it down here in the bottom right, because we're thinking about these angles in the top left, but all the r's are negative. So we're going to do the exact same shape here, right, except we're dealing with negative r. So we think about, we're first starting with these angles right in here, close to pi over 2, right? So the opposite of those angles is actually down here in this realm, right? Because again, we're dealing with negative r, and we're going to deal with the same sort of shape. We're going to come in pretty fast, we're going to level out, and then we're going to come back in along this other sort of guideline. We're going to end up with something that looks like this. By now, I think you guys are probably starting to get where we're going, right? We're going to again be positive. We're going to again be positive in this realm. Here we're positive when we're between pi and 3 pi over 2. So over here, we're positive. So I know you might want to jump back into the top left, but we're actually going to stay in the bottom left. We're going to come in along this tangent line here, in along this guy, right? We came in along theta equals 0, so we're going to go out along it. We're going to go out along it, and we're going to come back out. And we're going to make another petal of our rose again, and we're sort of going like this. We come in along 3 pi over 2, right? We come in along this vertical tangent line. We better leave also along the vertical tangent line. So this valley of our graph here, with these angles in the bottom right, these angles, where r is still negative, so we're actually going to appear in the top left. We came in along this vertical tangent line, so we're going to leave along this vertical tangent line and sort of sweep up to here. And then we're going to come back along this tangent line. Well, that was sort of more of a butterfly than a rose, right? I encourage you to check this exact shape out on Desmos. As you know, this was kind of a bad drawing. They should be closer to my tangent lines. It should sort of, it should look more like, nope, that's not it either. It should look more like this, I think. More like these guys. If you catch my drift, that's, I'm still not doing this justice very well. More along the lines of this, and then we have to come out and sort of do the same thing. Ugh, I'm having some trouble drawing today. Some trouble drawing. Well, nobody's perfect. Well, that one wasn't so bad. Not great either. Anyway, they should look a little bit more like that. Let's add some arrows on this last guy so we can sort of trace around. And we see that we'd sort of come in along here and then we'd exit on the way we started. All right, so if we wanted to number the points that we started at, all right, we started here. This was our second one. This was also our third one. This was our fourth guy. This was also our fifth guy. 6, 7, and 8. So we sort of start a pedal at each point. Okay, I think it's important to think about the coordinates of these points, right? Again, I think I misspoke maybe once or twice here, maybe more than that, who knows? Right, these are r comma theta here. So this is 3 comma pi over 4, right? That's the first sort of point that we came to. The second point we came to down here, we labeled it number 4 over here. Let's just be careful, right? We can talk about this point two ways with polar coordinates. We can talk about it as 4 comma 7 pi over 4, but really this point is, 3 comma 7 pi over 4. Really this point is negative 3 comma 3 pi over 4, right? That's sort of what led us to it on the graph, right? This guy here, it was positive 3 and 5 pi over 4. And then this friend up here was, again, negative 3 comma 7 pi over 4. So again, there are multiple ways of talking about each of these points, of sort of getting there. Right? Two maps would lead to the same place, but we have to be careful. So some things to notice about this in my general form A sine B theta. R equals A sine B theta, right? Well, we notice the absolute value of A could be negative. That's kind of scary. The absolute value of A, that is the pedal height or length or whatever you want to call it. Length, height, I don't care. That's sort of how far away from the origin these guys would get, right? And that makes sense because sine B theta can only be so big or so negative that would be sort of the maximum, right? Like an amplitude. And there turns out to be a rule here that if B is even, right, we'll have two B pedals. 2 B pedals. And we'll see next what happens if B is odd. We'll see what happens if B is odd. Okay, so let's look at one more example, and I'm probably not going to draw a t-chart just like the same way we did last time. You can, and you're encouraged to if you need to. I'm going to think about negative 2 cosine 3x, or negative 2, 3 cosine theta. This should scare some of us because B is odd, and secondly, right, that negative there is going to make our lives a little bit crazier at the start, but it's nothing we can't handle. Okay, so let's think about this. It turns out, right, I'll just complete this right now. If B is odd, we'll just have B pedals. Sorry for my poor penmanship. My class is used to it. Right, we'll have B pedals. So if B is odd, we'll just have 3 pedals. So we're going to expect 3 pedals here, and that negative 2, right, again, that means that the pedal length will probably be just 2. Up here, the pedal length was 3. I've sort of flipped my 2 and my 3 there and made the 2 negative. So let's hop right in and think about some peaks and some valleys, okay? So let's here are my valleys. We'll start with, negative way. Maybe the Penguins aren't playing well, and we want to think negatively about ourselves. So my negative points, negative 2 are 0 theta. Let's think about where on earth what on earth that means, okay? So if theta is 0, we're not going in to the right. We're going to go to the left 2. We're going to go to the left 2. So that's maybe here. Here's negative 2. 0, right? This is negative 2 comma 0. If you can hear my kids downstairs, I apologize. They're extremely loud right now. What about my next sort of valley here? Well, when we think about what this does to the period of the graph, right? What does this 3 do to the period of the graph? The period suddenly becomes 2 pi over b, right? 2 pi over 3. 2 pi over 3. So this point right here is in the x and y, this is 2 pi over 3 comma negative 2 in terms of x and y. So when theta is 2 pi over 3, that's up here, I also need to go negative 2 in the r direction. So that's down over here, maybe. Here's negative 2 in the r direction. Right, so what the point that made this thing, remember, the point that made this, the r was negative 2 and the theta was 2 pi over 3. Okay, let's keep that in mind. And then maybe we'll do one more. So again, that next one will be 4 pi over 3 and negative 2. So 4 pi over 3 is down over here. And in the negative 2 direction, that is up here. So this guy up here is really negative 2 comma 4 pi over 3. And maybe we'll see some interesting parallels here when I draw in my green guys. So my positive way, the Penguins will win tonight maybe. I guess you guys could be watching this whenever. Who knows? Maybe your lives don't revolve around a hockey team that you aren't on. It would probably be helpful for your sanity. Anyway, this point is pi over 3 comma 2 in the x y graph. Pi over 3 comma 2 in the x y graph. So where is that? Well, that's actually this same point. That's actually this same point, right? This is also 2 comma pi over 3, right? That's actually that same point. And I think you'll see that we'll hit all of these guys, right? This is actually also 2 comma pi, and this thing is actually 2 comma 5 pi over 3. Think about those 3 points. So we actually only hit some of these. And that's because of the fact that this is an odd function. I really only actually have to consider between 0 and pi, right? Because b is odd, I only have to consider between 0 and pi, but we'll sort of dive into how that comes about. Okay, so we have all these points, and just like we did last time, I think I used the blue color. I want to think about my zeros here. And I want to be sort of conscious of what those are. You guys could again solve this equation here. You could solve this equation and actually find those. Right, this is where 0 equals negative 2 cosine 3 theta, right? So 0 equals cosine 3 theta. So that would happen at what? Pi over 6, pi over 2, 5 pi over 6, right? It's going to happen every pi over 3 from then on, right? And sort of so on. And so those are all those points in the middle. Those are these points in the middle, right? So the ones that we know for sure are 0 comma pi over 6, 0 comma pi over 2, 0 comma 5 pi over 6. Okay, and now I'm going to draw in my guidelines again, because those were helpful last time. We're going to hope that they're helpful again. Okay, so I'm going to, Ethan is screaming in the background. I apologize. Hope that guy's okay, because it doesn't sound like it. I'm going to draw this one at pi over 6. Remember, I got that from this value here. That's from this point. Pi over 2, I'm going to draw one. That's right here. And lastly, at 5 pi over 6. So that's this guy right here. Okay. And then from these guidelines, it's sort of clear, these points that we've drawn, it's clear that we're going to have 3 petals, right? It should be fairly obvious that we're only going to have 3 petals, and it should be kind of clear of sort of where those petals will lie, right? They're going to lie sort of in this wedge, and in this wedge, okay? It's just a matter of thinking about where do we start, which direction do we go. And then sort of, again, if we follow the same rule as we did last time, where I sort of come in on a tangent line, go out on the same tangent line, we should be able to trace this pretty quickly. So we know we started at this point, negative 2 comma 0, out here. And let's think about what's going on, right? Normally, we're moving from 0 out, Normally we're moving from 0 up to pi over 6, right? But because r is negative, we're going to be going from pi, it's going to look like, we're going from pi down to negative, or to 7 pi over 6, okay? And we're going to be sweeping in, and we're going to go back to 0. So that has to look like, it can only look like one thing, right? This piece can only look like one thing. It can only look like this. And again, just like we saw last time with our in on one tangent line, out on sort of its opposite, right? We're gonna have to come out. Oops, I wanted to draw arrows. Arrow. We're gonna have to come out along this line right here, okay? And that should make sense because this is the first point that we visit, this 2 comma pi over 3. So we're going to come in along, or we came in along this tangent line, so we're going to go out along it. And we're going to sweep up to hit this guy. And we're going to come back. And again, once you start drawing these, it really just sort of goes. And you're sort of powerless to stop it, right? If you follow the rule of, I came in on this tangent line, I got to leave on it, you will eventually get back to where you started. Depending on how many petals you might have to draw. So we're going to now use this orange color. And again, I came in on the pi over 2 line. I've got to leave on the pi over 2 line, right? So we got to leave over here. And we're going to sweep up and we're going to come hit this guy, this sort of max petal. And then I'm going to come back along this route. Okay, I shouldn't have crossed there, but you guys get the picture. Okay, we come back into the origin. Right? And then we just have to finish off, maybe with this yellow color, right? We have to finish off going back into pi. Okay. And again, right, it just sort of went. Once we figured out which way to go from the start, we could have just sort of traced it the whole way if we had really wanted to, right? We knew we had to be going, from that starting point, negative 2 comma 0, we had to sort of follow this guy in and leave into the sort of the top right of the graph, right? And we sort of had to follow that. So again, the three meant we would have 3 petals because 3 is odd, and so I just have that many petals. You can see that, again, I know we're normally concerned with this 2 pi business, right? But that if we continued through here, right, we would just be tracing our own curve again. And there's sort of no way to get into these other 3 wedges, right? We can't ever get into there. So the 3 meant that we'd have 3 petals. The negative 2, I would say, right, meant petals were sort of too high. Petals were 2 units long or high. I don't know which way we want to talk about that. 2 units long or high. And I would say the negative meant be careful. Be careful to start. Be careful to start. So I encourage you to play again with Desmos. Sort of a great sort of way to experiment and learn here. Right, we saw, if I make like 3 cos 8 theta here, I'm going to have 16 petals because theta's even, and they're all going to be of length 3. You can play around here, right? If I have 7 theta, it's very different. It's only 7 petals. And you guys can sort of see, if you really think about it, you can sort of see these tangent lines if you zoom in. Right, you can see these tangent lines. If you pick any petal and you sort of trace your way back in, you can see how there's another petal sort of leaving along that tangent line. That's where I was after. And those are the zeros of your function. Right, if you were to graph y equals 3 cosine 7x, those would be the zeros of that function. So that's how we graph roses. Again, more information coming about your sort of the practice problems we're going to have you do. I hope you enjoyed this, and I do want to say, I promise I'd be entertaining. My class downstairs. I don't remember when my upstairs class Googled it. Also, we were being silly at the end of 1/6 period, and we Googled this cheese rolling, which you are very very encouraged to look up. These insane people basically running down a hill as fast as they can, chasing a wheel of cheese. It's as fun as it sounds. All right, I hope you guys all enjoy your break.